Hello, hello. Hello, guys. Uh, 3 minutes to our official start time. So, what questions do you guys have? Type them on the chat. Type them on the chat so that I know what you guys want to know about Zindi. Today we are going to talk about Zindi. Yeah, and welcome to my YouTube channel. I've always wanted to say this, but finally, the streams are here. This is the first stream, by the way. I've never streamed before, so if the quality is not good, be sure that the next one will be will be very good. So it's a learning experience. But anyway, I hope the quality will be good. So yeah, let's wait for our official start time. Then we start. Then we start. Then we start. Can see my friends here. Thank you for supporting the boy. Thank you for supporting the boy, man. Mon, James, my brother Ian. Thank you for supporting the boy. Cool. We can start. So today I'm going to talk about Zindi. So most of you probably have seen me talk a lot about Zindi, and you've been asking yourselves what this Zindi is. So I'm here today to answer all your questions. So Zindi is a platform for data scientists, not professional data scientists, but also there are professional data scientists there. But when I joined Zindi, the main the main collaborators or the main Zindians on the platform were university students. So I joined Zindi 5 years ago, nearly 5 years ago, when I was in first year, and that is thanks to the MMU, Multimedia University CIT Club. Uh, there were good peeps there. Lawrence, most Zindians know who Lawrence is. He's a grandmaster on the platform, one of the best to ever do it. A huge source of inspiration for me and for a lot of people. And when I joined Zindi, I never knew where this journey will take me, but here I am, topping the Zindi leaderboard. And I'm so proud of myself for never giving up. So, if you've never heard of Zindi, or if this is the first time you're hearing about Zindi, you can type on a browser Zindi. It'll the first the first result will be Zindi.Africa. Then you click it. For me, I've already signed in, but I'll sign out so that you can see how the platform looks like. So if you have never registered on Zindi and you're a student or anyone like a professional data scientist or an enthusiast, it doesn't matter your profession, provided you just are interested in doing challenges on Zindi. You click here, I'm an individual, then it will take you to the competitions tab. But when you look at your right hand side here, you can see the sign up form. It's pretty basic, honestly. Like they don't ask for a lot of details. You have your username, first name, last name. It's not a must you write your official names. But currently on Zindi they have like job boards, so it's good to use your like official names. Gender, you don't have to specify, and so uh, that's it. So for me, I'll just sign in because I have an account already. And when you sign in, you'll be greeted by a very nice UI with lots of competitions. Currently, open challenges are only four, and you can see the prize. Like the prize, the prize is a lot. To be honest, the prize is a lot, and you can win this prize. Like if you believe in yourself and if you put in the work. So hopefully after this session, we will solve one challenge. We are going to solve this Telangana Crop Health Challenge. But before that, the types of challenges that are present on this platform vary. So it's a good platform to learn a lot of machine learning, AI, or data science skills. For example, if we take a look at this first competition, this is a can you build a model for mobile phones to identify diseases on tomatoes, corn, and peppers? So this is a computer vision challenge. You need to build an object detection model. When you come to look at this competition now, it's can you predict the health status of crops? If you look at the data, it's tabular data. So most of the time, not most of the time, like the competitions vary. You can have a season where we have lots of computer vision problems, a season where we have most NLP problems, a season where we have tabular problems, and tabular including time series ones. This one, lacuna malaria detection, it ends in 8 hours. And so this also is an uh, object detection problem. And then this is going to start soon. So uh, when you click on a competition, if you have not joined the first time, you're going to be to see a button called join. So if you have not joined a competition before, you'll click join, and then it will ask you for you read terms and conditions. You can read them. You have to read them honestly if you don't know what you're getting yourself into, and then you can accept. If you accept, if you're authorized to access that competition, you'll be accepted. For me, currently, this is going to start in 6 days, so we don't have authorized access yet. Plus, it's regional. I guess this is going to be for Ghanaians. So sometimes it's like that. So you have competitions for Ghanaians, for Kenyans, for South Africans, for India, but most competitions are for everyone. Talking about competition rules, joining rules. For example, if you come to Ghana, this competition, if you go to rules, we're going to talk about all this, but if you go to rules, you can see this challenge is only open to citizens of African countries. Winners will be expected to demonstrate proof of citizenship. So if you're not an African, you can participate for the points. I'll talk about points, I'll talk about prizes. You can participate for the points, but you will not be you'll not be awarded the prizes. But if you come to Telangana, this if you go to the rules, you'll see this challenge is open to all. So competition vary a lot, and it's a good thing to like read the rules and understand which problems you're allowed to solve. But all challenges are open to everyone. Only now that the prizes will vary based on the rules. Cool. So that's basic overview. So I'll go straight to the competition we are going to try to solve, and we'll start with the basic description. So in the title, you can already see the objective. Can you predict the health status of crops? This is the objective, but this is too vague. So to understand the whole challenge or the whole project, you have to come to the description, the description tab. So from the description, it talks about the background of the problem. Ensuring food security through improved crop yield is essential for sustainable agriculture, blah, 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 blah. Now, the objective of this competition is to build a machine learning model that can classify the health conditions of various crops in the Telangana. Telangana, I guess this is in India. Yeah, state of South Central India, using data on cultivation practices along with historical Sentinel-2 time series data. So, in as much as I'm talking about this competition, there's a part of this competition that is not beginner friendly, and I'll talk about that, but that won't stop us from like building our baseline solution. I'll talk about, and that advanced part is historical Sentinel-2 time series data. I'll talk about that as well. So this model will help both farmers and government bodies monitor crop conditions and take proactive measures to mitigate any adverse effects on crop health and consequently improve crop yield. So that's the basic objective. So from the objective, you can see that the objective is to classify the health conditions of various crops. Then, when you scroll down, so this is extra background information about the sponsors. If you scroll down, the evaluation, you get the evaluation tab. So the evaluation tab is very important. Uh, so I can see a question here from Mon. What if someone who is not an African teams up with an African where the prize is only open for Africans? They'll get the prize if they're in the top three. No, they will not get a prize because if we go to that specific competition, the discussions, and I'll talk about the discussions as well, but to answer that question, if you go to one of the discussions here, it's very good to read discussions. So the first discussion, so questions who can join. I want to ask, is there two people in my team and only one person is African? Will I be eligible to receive the prizes? And then the organizers uh, the organizer said, or the competition lead of Zindi said, hello, all winners need to be African, i.e., winning teams need to be 100% African to win. So I don't think you can, if you have someone who is not African in your team, you'll be disqualified to win the prizes. But that's only for competitions which have those rules. But for example, this is open to all, so we don't have such rules. So we were at the evaluation tab. So the main objective of this, like this description or this info tab here, is to get familiar with the data, understand the problem people are trying to solve, and know the objective, know the evaluation metric. The evaluation metric is very, very critical. So I'll talk about two types of machine learning. There are three types actually: supervised and supervised learning and reinforcement learning. We don't have a lot of reinforcement learning competitions on Zindi, but we have, like, they have been there before. Like this year's Umoja Hack, I guess. Was it this year's? Yeah. One of the projects was like reinforcement learning. So there's a very diverse collection of competitions, so you won't be bored. Uh, so in most of the competitions on Zindi are typically supervised machine learning. And I'm going to talk about supervised machine learning today. You can read about unsupervised and reinforcement learning later. So in supervised machine learning, what you're given is historical data with labels, and then you're supposed to build a model that learns from this historical data, that learn patterns from this historical data to perform inference. And inference is just a technical term to say perform predict on unseen data. So unseen data doesn't mean you don't have columns, etc. It means this unseen data, you don't know the outcome, or you don't know. For example, in this case, you don't know the target. So his trained data will contain historical data with the target. Now your model needs to learn the relationships between uh, that data to form patterns that it will use now to perform inference on a test set that doesn't have this target column. So that's the basic, like the basic overview of supervised machine learning. This is like a technical description for it, but that's the simplest way I can explain what supervised machine learning is. So you can see evaluation metric. The error metric for this competition is F1 multiclass. So when you do a lot of competitions, you can basically guess what type of supervised machine learning this project is going to be based on the evaluation metric. So for this case, based on this evaluation metric, F1 multiclass, this means it's a multi-classification problem or simply classification problem. So we have classification problems and we have regression problems. In regression, you predict continuous variables. So, for example, if a tourist comes to spend time in Kenya, how much money will he spend? So money here is continuous. It's not binned into specific categories. But now classification, you don't predict continuous variables, but you predict discrete variables. So discrete variables, they have been binned into different categories. So multi-class means it's more than two classes. Then binary classification means it's only two classes. So for example, if a person will defaults alone or not, that's binary classification because you have yes, he will default, no, he will not. But in this case, we have four categories. So a plant can either, so from the objective, that can classify the health condition of various crops. So a crop can either be diseased, can either be pests, can either be stressed, and can either be healthy. Healthy encompasses healthy and good conditions. So we have four classes. That's why we are using F1 multi-class. And classification problems and regression problems, they have different evaluation metrics. That's why I said you can easily tell a competition it's which subset of supervised machine learning based on the error metric. For example, classification, we have multi-class, I mean F1, we have area under the curve, we have accuracy, which is what most people know. We have log loss, we have recall precision, and each one of these metrics have their own use cases. So for example, in this competition, you will see why they used F1 and why they never went with accuracy, and we're going to talk about that. So for regression now we have different metrics as well. We have mean absolute error, which is the difference between the actual predicted value and I mean the actual value and the predicted value, the difference. Then root mean squared error is the difference between the predicted and actual but squared. And then we have mean absolute percentage error. We have we have others like SMAPE, but the commonly used in regression are mean absolute error and root mean squared error. Root mean squared error is used in datasets where we have lots of outliers in the targets, and mean absolute error is used where there are no plenty outliers. And F1 and accuracy, there's also a difference. So I'm going to talk about it here. So F1, in most cases, it's used when the data set is imbalanced. And what do we mean by imbalanced? A better way to understand imbalance is by going through the data. Cool. I've talked about evaluation. And so there's an extra evaluation, but this you have to keep it in your mind though, but this won't be used in the leaderboard. And we're going to talk about what the leaderboard is, what the private and public leaderboard are. So fairness metric, the top 20 after the competition end based on the F1 multi-class, the top 20 on the leaderboard at the close of the challenge will have their top two public scores, submissions on their two selected submissions scored against this uh, this custom error, like custom error metric. So holistic AI bias metrics multi-class equality of op. So this will only be applied to the top 20 on the leaderboard. So currently, the timeline of this competition is the timeline on this competition is until 9th February. So until 9th February, the evaluation metric you're going to see on the leaderboard is F1 multi-class. Then after the competition ends, the top 20 will submit their code, and then their code will be ranked based on the holistic AI metric. Cool. And then also, if you're ranked in the top 10 on the combined leaderboard after the challenge, you'll be required to submit a PDF document containing your answers to these questions. Each answer should be between 100 to 300 words in length, and including references in your responses will strengthen your submission. These questions are designed to challenge your thinking around fairness and the practical application of AI. Please note that your solution will not be eligible for review by the code review team until all questions have been answered in sufficient detail. Each part of the question is addressed thoughtfully and clear reasoning or examples are provided. So in most competitions, we don't have qualitative report, but this year Zindi has the most competitions that Zindi has hosted. People have been required to submit technical write-ups or technical papers to competitions after the competition ends for the top 10. This is not like for everyone. This is only for the top 10 people who are going to be like considered for prizes. So if you're in the top 10, remember, you're going to be evaluated in this fairness metric. So you have to keep it at the back of your mind. And there's also a qualitative report that you have to write. Most competitions don't have this like in the past like 4 years, but this year there have been a lot of competitions where the report has been like a required necessity for you to like be awarded prizes. And now to the fun part. So this is what this is what most people love about Zini competitions. So there is a lot of money to be won. So for example, I personally am Kenyan. If you're in the first position, you're going to be awarded 3,100 euros. If you come here to convert these 3,100 euros to Kenya shillings, you can see this is nearly 400 and so this is for 421,538 shillings. And you know what? The fun, the like most exciting parts, you don't have to do anything. Like the only thing you have to do is sign up to this platform, participate in a competition, show your creativity, and this money will be yours if you win. So it's just simple as that. No, like, uh, okay, I don't want to use this word because Kenya Tech Twitter will come here in flames, but it's simple to like get started on Zindi, like, and to win prizes on Zindi. You just need to participate in a competition, win, and get the prize. Simple as that. So other than that, there are Zindi points. So points are also very crucial. Points contribute to the prestige tag, or for example, in Kaggle, they call it the Grandmaster title. So in Zend, we don't have a term here. I don't think people have discussed what terms should be given to the like top people, but there is a leader, like there's a overall leaderboard. So there's this leaderboard here. This leaderboard is for the competition when the competition is ongoing. So this is specific to a competition. But after the competition ends, this these points will be awarded to the top, like I guess it's top 50, but it depends on the like the amount of points you'll be awarded. It depends on an decay metric that I'll show you as well. So for example, here in this competition we have 7,000 Zindi points, right? So if a person wins, for example, if the current number one wins, Loazi, if Loazi wins, he will have, so let's go to his profile. So his profile currently is in current rank 1095 and he has 377 points and the current rank is 1095. When he wins this competition, the total points he'll have 7,377 points. So when he gets those 7,377 points, his current rank won't remain the same. So what is this rank? So if you go to the current navigation bar, you can see we have a community tab here. So if you click the community tab here, there's an overall leaderboard that ranks everyone who is participating on Zindi based on the competitions they have participated in and which position they are in. So currently, and I'm not boasting or anything, I'm the current number one with 33,000 points, Zindi points. So these points came from me winning competitions and being mostly top 10 in most competitions, as you're going to see. So, for example, now, after I've forgotten his name, the first person on the competition currently wins that competition, he'll have 7,377 points, right? So, which position will he be? Remember, he's in current rank 1,059 or something. But when he wins and get the 7,000 points, he'll have 7,377. So he will have climbed the leaderboard almost 950 positions. So he'll be position 31. Yeah, because Glandax here has 7,414 and Sandro Who here has 7,118. So you can actually see that Zindi points, in as much as they are not, it's not money. It's not money. It's just points. They have like a sense of prestige or sense of a grandmaster title or something that elevates your position on the Zindi leaderboards. So I'm going to take I'm going to take a sample user to show you the power of points. So Makai Barry, him before like 2 weeks ago, he was not even position top 1,000. He was not. But then he participated in a competition called Smart Energy. You can see he ranked number one out of 128. So if you go to this competition, you'll see in the prizes tab, the first prize is 8,000 CHF and there are 18,000 ZD points. So in this competition, he won first place, and if you win first place, you get awarded all the points, like 18,000 points, like you get all the points. So initially he had 290 points, but then he won Smart Energy, and he got all the 18,000 points, and now from like below 1,000 rank, he's now in top five. So how does Zindi award these points? Like you have to ask yourself, how does Zindi award these points? Because they vary within competitions. So each competition has a prize tag. So if you look at this competition, the total prize tag was 18,000 CHF. This is a lot of money. This is a lot of money. So the Zindi points translate to the amount of money awarded. So if there are 18,000, if there is 18,000 USD to be awarded, you will have 18,000 points. So if there is 5,000 USD, this is total prize money. If there is 5,000 to be won, that will translate to 5,000 points. So you can see, you can argue. For example, Makai Barry, yeah, we are going to study him. He has only one gold medal and only one silver medal. All right. But then, if we look at someone like Krishna Priya, for example, he has a lot of gold medals. He has 7 gold medals, 5 silver medals, and 1 bronze medals. So you're going to ask yourself why Krishna has 7 gold medals and Makai Bari has one gold medal, and he's on top of him. So that's the fun part of the leaderboard. The leaderboard expects you to be very active, and it awards people who are active on the high-end machine learning projects on Zindi. So, for example, you can, for example, my rank at the moment, the 33K, it's a lot, yeah, it's a lot, but all you need is only two smart energy type competitions because you'll have like 18,000 points, and that will be 36K, and you'll be on top of me. So you just need to win two high-end machine learning projects on Zini. So if you win only two, you'll have only two gold medals, right? I'll have 25 gold medals, and you'll still be on top of me. So it's funny like that, and it's fun because now it's like winning a belt. It makes you want to defend this title, and that's why this is a trick Zindi uses to keep people engaged on the platform, and I can't complain. It's a very cool tactic. The same as uh no, not the same as Cargo. Cargo does this as well. So how for example, how does all these other people like 2, 3, 4, 5, 6, how do they get how are the points distributed among them? So if you come to talk here, you'll see there's a discussion. I, I can't remember the exact name, but it's called Zindi Zindi points. I think if it's yeah, Zindi points. So it was a recent one. How to calculate Zindi points. If I get the correct link, I'll link it here. Or if someone on the chat has that link, you can link it here. So they have a specific mathematical metric of how to assign the Zindi points, and also the Zindi points decay. So if you come here after some few days, I won't be having 33K 485 points. Maybe I'll have 33,200 points. They decay if you don't participate actively in multiple competitions. So I've talked about the description, I've talked about the prizes, I've talked about the points. So I've talked about the evaluation, timeline. Oh, timeline. I'll talk about the time. Timeline is how long the competition runs. So, and it's clearly indicated on the title as well. So for these 3 months left, we have a lot of time to experiment on this competition. And these are real world problems. These are real world problems. The only difference between this and what data scientists do at work is that data scientists here, you're provided with the data, and at the workplace, you are the one supposed to come up with the data, or together with the data engineers and maybe data analysts. But here, you're provided the data, but not all the data. For example, in this competition, you have to create your own data based on Sentinel-2 satellite images. And that's why I told you this is not beginner friendly, but it has a part which is beginner friendly, which you're going to discuss today. You don't have to like go to the Sentinel-2 images today, but you can. They have. I'll talk about the data page now, and then you'll understand. So in the data page, they give you the data sets. So for example, here I've told you don't have to create your data yourself. You're given the train set, and train contains the target. The way I explain supervised machine learning, you're given historical data with target values for the train sets, and you need to predict on the test set. Like, as you can see, test resembles train, but without the target related columns. So you won't have the target, you won't have the target column here. So that is what you're going to apply your model to. And then you have variable definitions. This explains each of the definitions have been given, like the columns attributes have been given. Sample submission to show you how a data set you need to submit on Zindi looks like. Start a notebook. So multiple competitions. Zindi makes sure you have the right things to get started. They make it easy for you. So there is a starter notebook you can use. And this starter notebooks, by the way, goes even into detailed feature engineering techniques like the one I talked about, accessing Sentinel-2 image data and calculating new features, new powerful features called vegetation indices, which I don't think you're going to go into tonight, but during this like a series of videos, maybe we'll talk about it very soon. But the starter notebook has that. So here you just get the data sets, and then it explains to you how what the data sets are, the type of data sets that have been provided, the starter notebook, etc. And now here we have the discussions. So Zindi has a community. They are very helpful people. For example, Muhammad, shout out to Muhammad. He has provided a starter notebook for us uh, that you can easily access. And he tells you this notebook scores 72.2 score. If you come to the leaderboard, if you look at 72.2 score, it's a good starting point. You'll be at, let's say, position 42, right? It's a good starting position. So uh, you can go check it out. So for example, here, and to access this data set, it's pretty easy. All you need to do is copy and edit, but you have to, there's some prerequisites you need to do to make sure this code runs on Kaggle, because you have to download the data sets. Yeah, we're going to do that. Cool. Now, team. Also, discussions. Here you'll post all your problems that you're facing, and kind Zindi participants will help you to solve the issue. So Zindi does not allow you to share notebooks outside our team. So if you have a problem and you want to ask someone, for example, if you have a problem and you want to ask me, you cannot come to me directly and ask me, oh, this is my notebook here. I have this problem. No, you can just come and post it here on the discussion, and I or other very cool people will answer you and help you solve the problem. The leaderboard. The leaderboard is the fun part. It gives you adrenaline. It gives you constant, constant reminder that you need to push. You need to push. Your weekends should not be boring. If you're working like me, because the only time you get to work on competitions is either weekends or late at night. So the weekends, it's time to push your rank up the leaderboards. So uh, the goal is to beat the best performing score. That's the goal. So if you beat the best performing score, you win. That's the basic idea. Team, you can form a team. So for example, uh, you can form a team of up to 5 people, I guess. So if you go to the rules, if you go to the rules, teams, you may participate in challenges as an individual or in a team of up to 4 people. So you can join a competition up to a team of 4 people. So you don't have to solve the problems. You don't have to solve the problems alone. You can team up with your friend and participate in the competition together. Sorry, let me charge my laptop. Cool. So up to 5 people, up to 4 people, up to 4 people, up to 4 people. And creating a team is very easy. So you come here, you say you call you you define your team name. For example, I love Central Park. I remember my best Zindi teammate Johannes Melis. I I really respect that guy, and he played a part in pushing me to this top rank. Honestly, when we started Zindi together as beginners, we used to form teams together, and Central Park if most people have watched, I know most people here have watched Friends. So Central Park is where the Friends group were going to meet for coffee. Was it? Yeah, I guess. So Central Park was our favorite name. So you come here, create your team, and then when you create your team, you can invite people. So you have to enter a valid Zindi name. So for example, I have here on the stream we have Moan. Moan, the valid Moan name. I don't remember his valid name, but I think is Moan something like that. But for example, my Zindi teammate is called Johnny. So you enter his Zindi name, then click invite, and it's as simple as that. You have invited someone to a team. But remember, when you form a team and you make a submission, you cannot disband that team. So it's advisable to participate in a competition solo until maybe 1 month remains. Then if 1 month remains, for example, for these long competitions where we have 3 months to participate in competitions, when 1 month remains, you form a team with your best mate or your schoolmate or with your friend or with someone random. For example, Johnny, Johannes, is from Ethiopia. Here you will find people from all over the world. You'll find people from Asia. You'll find people from America. You'll find people from Australia. You'll find people from Africa. Africa are the majority though. So you have people from Tunisia. Tunisia and Nigeria have the very like high performing people, like high performing individuals on Zindi. Like they are so good. And now, me and Julius, shout out to Julius. Me and Julius are repping the Kenyan flag high, man. Like I'm so proud of us. I'm so proud of us that you're letting them know that even Kenyans are so good, man. It's not only Tunisians and Nigerians. We also have Kenyans. So yeah. So you can form teams with people from all over the world, and don't be afraid to DM people and ask them to team with you. Like most people here are very open to teaming up. So yeah. So remember, when you make a submission as a team, you cannot disband a team. So the only time you can disband a team, it's it's only if you've not made a submission. So how to do that? You disband team. Do you really want to disband a team? Yes, and that's how your teams Maxwell, you're in the top two. Yeah, soon, very soon, man. I'm expecting 1, 2, 3, 4, 5 to be Kenyans. I'm expecting 1, 2, 3, 4, 5 to be Kenyans. But Kenyans are really good. I'll show you. I'll show you. Kenyans are really good. Cool. And then submissions. Here is where you submit. You choose a file. Submit your files. Cool. And you're done. Now, that's the basic overview of the Zindi platform. I've shown you everything you need to know to get started. So it's so easy for you. I've explained how a competition is organized, like the info, the background story, the objective, the evaluation metric. I've shown you the data page where you're supposed to download the data, the discussions where you have to post your issues and people will help you, a leaderboard where it keeps your adrenaline high by constantly reminding you to push up the leaderboard, and team, how to form teammates with their mates, how to submit, how to submit, how to submit a submission file to be ranked. So in Zindi, you submit a CSV file to be ranked, and I'll talk about the CSV in the project. So the only remaining thing I've not showed you is here. You see this message tab here. So you can start. So how do you ask someone to form a team? How do you ask someone to form a team with you? So for example, in Lacuna, my friend here, Mon, we teamed up with Mon. So you can see our team name is ML and Kingsdale, and it's for the Lacuna Malaria Detection Challenge. So Mon's name is Nyatuka. So if you want to DM Mon, You come here, start a private discussion, and select the person you want to send the message to. You can see you have Nyatuka, and then polite subject, team, team, what can I call it? Team join. Uh, hello, Moan. Do you want to team team up with me? Yeah, and you tell him in which competition. So, for example, in Lacuna, malaria detection, and then after you do that, there's supposed to be like a send button. I don't know where it is. After you finish, you click send. So I'm not really sure where the send button is. I think then you'll have to fix that. But after you finish typing, you send to the person you want to team join with, and then the person will reply. So, and you can, it's not only for team joining. You can like talk about, you can talk about the problems you're having, but it's not supposed to be private. Remember, it's not supposed to be private. If you are found, you get disqualified in a competition. So every team, like every request to our fellow teammates. Oh, send is at the bottom of the page. Oh, I never saw that. Oh, I see now. My screen, man. Cool. Then you click send. Nice. And then Mon will reply. Mon, if you're in this stream, reply so that people can see how these chats work. Yeah. Plus, also you can ask them for their WhatsApp numbers for knowing people. For example, Johnny, I wish I can find teammates. My first teammates. I have lots of discussions, man. I wish I can find the first one is Johnny. Because Johnny was one of the first people who asked me to team up with him. So, uh, let me search Johnny. Uh, okay, I cannot see our team words message, but yeah, this is the guy, Johnny. Yeah, cool. What else? Oh, profile. So when you win a competition, I don't wanna, I don't wanna show, but people can go on Zini and just look at it. So if you go to competition, I mean, if you go to your profile, you'll have to fill in some details. So where is it? Edit profile. Yeah, yeah. Here, edit profile. So if you come here, you have to like fill in some details because now Zini have a job board. Zini have a job board. Moana sent the message. Huh? So let's see. Let me refresh. Yeah. Moan has replied, sure, right away. Then, when the person has accepted your team request, you come to the specific competition you want to join as a team. For example, Lacuna, you come here to the team part. We already have a team. We already have a team. So you follow the team creation procedure that I already showed. Yeah. So that was cool. That was cool. Thanks, Mohan. Yeah. So in your profile, you have to fill in your profile because Zindi has job boards where they refer top performing data scientists or machine learning engineers, whatever you want to call it, based on how you have uploaded your CV to companies. So you can easily get a job from Zindi. So another perk of being on this platform. So you can come here, edit your profile, edit all your social presence, your CV, etc. Then you can win badges. So, for example, these are my badge collections. And then competitions. When you win a competition, you are ranked. For example, in this competition, I was ranked position one. So you'll always see your rank. So this should not like discourage you. And I show you my my first competition was like one of the last people. So it all starts from the last position, then you climb up. Yeah. So what have I missed? What have I missed from the Zindi platform? What have I missed? Can you type on the chat? What have I missed? What you would love to know about the Zindi platform before I move to the project now, to the coding? Yeah. I finished the platform. I hope everyone has understood the platform. Now I wanna move to the I wanna move to the coding parts. So any other questions you got? Oh, so someone might ask, how do I get started? I don't even know how to write a data science project. Oh, we are going to write one here on live, but we have get started with practice challenges. But my opinion though, my opinion, I don't think starting with practice challenges will motivate you enough to like participate in other competitions. My opinion is to always start with prize money competitions. Always. Like I can show you a practice challenge here. Financial inclusion has 1,000 participants, and if you go to each of those participants, most like 75% have not participated in any prize money again. I mean, prize money competition again. Like you go do a practice challenge, you think you have understood, but no. Where the fun is at is where there's money. Where there's money, so that you get motivation, man. Like go to the prize competitions. This is my point, my opinion. Yeah, my brother Ian is a victim. He only does financial inclusion, but when it comes to, to the prize money competitions, he gets like he feels afraid, or what is it called? Imposter syndrome, yeah? Imposter syndrome. Don't feel, bro. I have a friend. He's called Mohammed Lue. Mohammed Lue won his first competition. The first prize money competition he joined, he won. So what's stopping you? Like I can show you. He won his first ever prize money competition. He bet the veterans, including me, including Kina Professor. So I'll show you. He's called. I'll go to Kenya. He won his first competition. That's crazy, man. That's crazy. Here he is, Louis, a very good friend of mine. Look, this was his first competition. Actually, two competitions, man. And I remember though at the same time, he joined this competition and and won. Louis, like he really impressed me. He really impressed me. Like he did something I could not when I first started. His first ever competition, he joined and won. And in this other competition as well, he came second. He came second. You can see, like, all you need to do is start. Believe in yourself. Believe in yourself. Believe in yourself, man. Believe in yourself. You will not, you will not fathom where believing in yourself will take you. I joined Zindi 4 years ago. Let me show you. I had an account which I lost the credentials. So let me search it. My first co Yeah, this was my older accounts. Like I lost the credentials. You can see my first competition. I was ranked 203, 203, man, 203, and now I'm rank one. Hey, bro, when I started nearly 5 years ago, this I could not even imagine. But I kept on fighting. Why? Because I had people I was looking up to. At that time, if you go to the community and search for Kenya again, my school mentor, he's called Lawrence. He was the one leading the competition. Actually, I'm position one this time, but I can name you guys here on Zindi that I'm not at their level. Like I can't, I'm not at their level, bro. I'm still a beginner. I'm still a beginner. I'm still learning. But there are people here like Lawrence Moruya. I'll show you. And yeah, Lawrence. Where is Lawrence? Uh, here he is. Don't be fooled by the don't be fooled by the rank. But this guy is a beast. This guy is a beast. He was my motivation to join Zindi because he was our CIT club lead. And when I joined first year, he had won, I guess it was a Umoja hack or something. And that motivated me. Like essentially, it told me if a person from multimedia can win a competition of Africans, of the whole Africa, who am I not to win? That's initagwa as brain teaser. Brain teaser to you guys. Motivation for y'all. And now let me show you our female queen. I'm not at her level. I'm not at her level like Igwe. She's called Plato. Plato, Plato is so good. Like, bro, Plato is so good. The reason why I'm on top of him on the leaderboard is because I think she retired. That's the only explanation, man. But she is so good. She is a girl. Zindi currently suffers from girls not participating in competitions. Like, I don't know why. Like, she'll be your motivation, man. She was like, if you can see, best rank number two. She was at some point number two on the leaderboard. Look at the competition she has won. Like, bro, I even aspire to be her. I'm not even at her level, man. Like, look at the competitions. And it's solo wins. Like, solo wins. No teams. Solo wins. Like, bro, there are Kenyans out here who are so creative and so cracked, man. Like, they are so cracked. And that person can also be you. You just not, don't believe in yourself. This is my wake up call to you guys. Kenyans, wake up. Wake up, man. Wake up. Julius and I should be your motivation to work harder. And so if you come to the Kenyans, Ronnie. And it's funny how the top one, two, three, and also Mon, like they are my close friends. And I think we motivate each other to keep on like pushing. And maybe starting these streams will be a motivations as well to all the people watching the streams. So you can see we have two Kenyans, one, two. Ronnie is another one. Look out, look out for Ronnie's Indians. Look out for Ronnie. Ronnie is also very good, man. Like he is so good. He is so good. He really outsmarts said a lot of us in a recently concluded competition called Melio. He was so good, man. Respect Ronnie. Then I don't know Nad. I think I need to like we need to like uh connect with Nad. But I know Julius. Julius is a very good friend of mine. Shout out to him. I know Ronnie. Ronnie is Adept Schneider. Plato, we have not like personally interacted, but bro, I look up to her and I wish this coming year I get huge wins. Huge wins like hers, yeah? Cool. Okay, I think 1 hour was enough for the platform. That's it. That's it. Now I want to go to the coding part. I want to the fun part now. I want to go to the fun part. Cool. We are going to come back, but to only submit. So how to get started? How to get started on Zindi? So everyone here uses different operating systems. So the people who love Windows, I currently am using Windows. I also have a laptop that uses Linux, and other people too, like Mac OS, Linux, Windows. So all these operating systems, I won't be able to like go to the nitty gritty of how to install like Jupyter notebooks on them. No, I'm going to use cloud notebooks, and this is free for everyone. This is free for everyone. They offer you free GPU, they offer you free compute, and they are very easily linked. Like you can upload your data sets, you can do a lot of things. So I want you guys to follow along with me. So come here to the data page, download all these files in archive. It won't take like a long time. I think when I download, you guys won't see my file manager when I uh, extract the zip, but it's simple. Like this is basic computer computer stuff. Download, extract the zip. Then, because this competition will eventually ask you to link your Google Earth account for the Sentinel-2 images, which you're not going to do today, but it's good to use Google products for this because you have Google Earth, which is easily linked to Google Colab. So for Google, we have Google Colab, and also Kaggle is also Google's. But I'll tell you the pros and cons of each. So Colab is easy because all you need to do is go to your Google Drive, go to your Google Drive, you go to your Google Drive, go to your Google Drive. This is my personal drive. Then all these you can see these were past Zindi competitions. So you can see plastic cover map. This ended like yesterday or 2 days ago. All you need to do is come here, folder upload. So this Google Drive should be the one, like the Google account you are accessing your Google Drive in should be the account you have linked to your Google Colab as well. So you can see I had Telangana somewhere here, but okay, in my other laptop, but you upload the folder. So when you upload the folder, you'll see all the files that are present here, like test, train, sample submissions, data notebook, variable definitions. You'll see them here. So you have data, sample submissions, data notebook, all of them, they're present here. So if you are curious enough to see how the problem looks like, but I won't advise beginners to look at the starter notebook because it's a bit technical. We can actually look at it. Doesn't hurt. So today we have already finished this. Now we are going to solve a challenge. So if you go to open notebook, I had the starter here. I can open the starter notebook provided by Zindi. Here, it's a bit technical. You'll see a lot of Google Earth stuff. If you've never seen Google Earth stuff, this will probably demotivate you to continue this project. But I'll tell you, don't. We are going to go via a very easy step. So you can see they're connecting Google Earth, to then download the Sentinel image data. So let me explain this project in a nutshell. In this project, you are given farmlands. In these farmlands, they grow certain crops. You're supposed to predict if these crops are healthy or are diseased or the other two categories. These farmlands are given in a polygon column, like a list of large long, which represents the points of the farm. You need to go and download Sentinel-2 image data, calculate the vegetation indices, add them to your existing data frame. But as you are going to see, you can actually solve this problem as a baseline. This is a baseline without that complexity. So starter notebook is a bit technical, but it helps you. So if you want to go look at the vegetation indices parts, you can, yeah. So Google Colab. So how do you access Google Colab? You search Google Colab, and if your browser is connected to a Gmail account, you can access it. You can click this, it will take you to one of these. So we can actually do it. So if you click here, you come here in the file section and then create new notebook in Drive. Click new notebook in Drive. I don't want to do that because I've already done it. So stream one here. So first step, tell me if you guys are following along. This kind of code mwenye, I hope this will take 1 hour. If it doesn't, I don't mind extending it to like 3 hours long, but we'll see, we'll see. I hope it takes, I need to explain everything because I'm assuming most people have never like solved their first Zindi challenge. So I'll 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 take my time. I'm not in a hurry. So I need you to get, because bro, if you don't code along with me, you won't have any other or you'll have multiple other chances, but you won't have the same chance as today. Because I want to repeat the next stream, I want to repeat everything that I've done today. So get your laptops out, man. Get your laptops out. We code together. Okay, as long as Mohan is following, I'm assuming everyone is following. So if you upload your data to Google Drive, how do I access the data? Go add water first in your bottle, man. It's full. It's almost full, man. How do you, so you have uploaded the data to Google Drive. Oh, before I continue, Kaggle as well. I talked about Kaggle. You have to have an account though. And Kaggle is actually my go-to. The only reason I'm using Google Colab today is because of the Google Earth stuff, because I want to keep my project intact. You can also use Google Earth stuff on Kaggle, but it won't be as seamless as Google Colab. So when you download the data, for example, you come here to the datasets tab. Let me repeat that. Come here to the datasets tab, click new datasets, browse for files, select the downloaded. So in Kaggle, you don't actually need to extract the zip. You upload the zip itself. When you upload the zip itself, so let's upload uh, let's upload one model here. Yeah. So it will show you a progress bar somewhere here that it's uploading. Then you need to enter a unique title. For example, in this will be Lacuna models updated. So in your case, you'll name it as the same as the challenge. So maybe Telangana, and it will have all the data sets that you've downloaded. Then you click create, and it will start creating your data set. So this will take a while because it's a huge model. But yeah, I'm going to quit, but I'm going to show you my data sets that I've created. So Telangana, here it is. So you can see I downloaded it, the zip itself, and it has all the data here. Then when you have the data in Kaggle datasets, all you need to do is click New Notebook. When you click New Notebook, when you click New Notebook, it will create a new notebook with the datasets already uploaded in the working memory. So for example, here you can, like in the input part, you can see the dataset has been loaded. So to access this dataset, so you can rename this because it's randomly generated. So you can rename this to, let's say, Telangana notebook. And then we have initialized it with default Zindi, I mean, not Zindi, default data science libraries, which are essential in every data science project. But you can delete it because we are masters of our own self. We can write the code ourselves now. But plus it was too verbose. It was too verbose, yeah. So import pandas as PD. I'm going to show you just loading the data. So train is equals, now this is loading the train sets, pd.read CSV, and test you do the same. So copy, paste, test, and then select, and oh, I haven't shown you what I'm doing. So you come here to your inputs. So it was like this. You come here to your inputs. For each data set you want, you click this copy on the right side. So for train, you click copy and you paste between the two string quotations. For the test, do the same, and so it's going to start. You'll have your train, so you can verify if you have loaded the data correctly. So we use display train.head test.head. Nice. So all you need to do is now wait patiently. It won't take long. Voila, we have our data set. So pretty, so cool. So you can see train.head, and now let me show you. The targets we are going to predict is this category. As you can see, this category right here is not present in the test data. Remember, train comes first, test is displayed last. So you can see this category is not in any of these columns. Why? Because, as I told you before, in supervised machine learning, you are given a tensor to the historical data that has the target variable. In our case, category is the target variable. It will only be provided for the tensor. What your task is, and your only task in this whole project thingy, is to predict the category for the test dataset, because that you don't have. Once you predicted category for the test set, you submit the predicted values for that category to Zindi. Then Zindi, they have the actual values for that test set, only that they don't provide them for you. What they do, they run it side by side using a metric defined, in our case, F1 score multiclass, and that is what they use to rank you on the public leaderboard. That is what they use on the public leaderboard. So your only task is to predict the category in this project. In all projects you'll be given, your only task will be to predict the target variable of that project. Simple as that. That's computational machine learning for you. Work stuff may be a bit different, but computational machine learning, it's as simple as that. Predict the target variable, submit to Zindi. Zindi will do everything else, like rank you. But at the end of the competitions, you have to provide the whole code for how you generated the targets. Cool. Uh, so I'm going to now shift my use case to Google Colab. So you can continue everything we are going to do on Google Colab. You can continue here on Kaggle, following the same steps. The only difference is how the data is loaded and how Kaggle kernels work. So this is called a Kaggle kernel. It's cloud-based. You don't have to have like 8 8 like more than 8 GB RAM on your laptop, or you don't have to have a GPU to run deep learning models. They have GPU for free. So if you select here, you can see, man, like two T4s, one P100. You have even a TPU for use. So you can do a lot of deep learning things here, man. But it's only limited for 30 hours. So you can see if you select GPU, you'll be told availability is limited to 30 hours per week. But 30 hours per week is a lot if you're not training huge models. Cool. Now I'm gonna quit Kaggle. I'm going to go back to Google Colab. So the same things you're going to do here, other than the data loading part, applies to Kaggle. So how do we load our data from Google Drive to our notebook environment? So what you do is from google.colab import drive. So this is your drive, and make sure the Colab notebook you're using is the same one as the one you have stored your data in. So for me, it's the same. So you can you mount the drive. You can mount it as content drive. Okay, you can we can go with that. So what this will do, it will prompt you to connect your Google Drive. So don't be afraid. You can read the rule, like you can read the what Google is prompting you, but it's nothing malicious. So yeah, permit this notebook to access your Google Drive files, connect. So you can see this is the same Google Drive I used to save my data. And then continue. Continue. Cool. Also, Google Colab has everything Kaggle has, but. Google Colab is a bit stingy with the runtime because they only provide you, I think, 7 hours continuous runtime for one day, and then next day you want to get 7 hours, you'll actually get less. So it's like it's not consistent. So that's why you either pay for Google Colab Pro, which you don't have to. You don't have to. You only pay if you want like consistent runtimes. If you don't, they'll give you free GPUs. So if you come here to view resources, you can see, oh, not here. If you come here, I hope okay, yeah, that's better. So if you come here, you change runtime type, you can see all the GPUs will be provided. You'll only be provided T4 GPUs for the free version. Only one T4 GPU. So Kaggle provides you with two. Here they provide you with one. If you pay, so I have Google Color Pro. That's why you see a Pro here. You can get a 100 or L4 GPU, or you get a TPU also in the free version, I guess. But yeah, these are the higher end GPUs you get after paying. But currently I don't have credits, so I also cannot access this. I can only access the 4 GPUs. Because by this project you don't need a GPU really. We might, but not at this point. Cool. Once your drive is mounted, if you click so if you need to click these files, you will see the drive has been mounted here. So if you look at my drive, we need to search for the project Telangana that we created. So it's here, right? And it has all the data. So what you need to do is advisable, since all these files stem from these parent roots, it's advisable to create a parent path, then use this parent path concatenated to the file names of each. So that's my go-to pattern. So I create the path. Then if I want to load my train sets, all I need to do, sorry, you need to import libraries to load our train sets, so our data sets. So pandas. So what is pandas? Pandas is a library in Python used to manipulate data frames. Simple as that. If you want extra explanations, you can ask ChatGPT for clearer, more detailed instructions, or you can Google. So, oh, prerequisite, you need to know Python. Prerequisite, you need to know Python. Yeah. So PD read CSV. Then you're going to specify the path plus the train. So I have the AI here that is helping me. So train.shape, test.shape. Oh, cool. Now we have loaded in our datasets. We have train.shape. The train set has 8,777 rows, 20 columns. The test set has 3,016, 19 columns. So, my bro, Kid Not, Ian, can you type on the charts? Why? Okay, not you only. Like anyone on the charts. Why does the test have 19 columns and train only has 20? Oh, and train has 20. Why does train the train has 20 columns and the test has 19? Why? Anyone on the charts? Anyone on the charts who has been following? Anyone on the charts who has been following? I've explained this exactly. Thank you, Maxwell. Exactly, man. It's because the test doesn't have the target variable. It doesn't, and that's supervised machine learning for you. Train has historical data. It has target variable. So your model needs to learn from the train data the relationship between independent features. So independent features are all the other columns except the target variable. The target variable is called dependent feature. So your model has to learn the relationship between all the independent features and how they map to the dependent variable, which is, in our case is category column. Thanks, thanks Maxwell. Thanks Maxwell. So train.shape. So we have seen train.shape is used to view the number of rows and columns. Now we're going to a very other standard pandas method. It's called the f.head. So we don't have the f here, true. So we are going to display train.head. So train is a pandas method that helps you visualize the first 5 rows in a dataset. The first 5 rows. So the opposite is also true. When you specify train.tell, it shows you the last 5 rows. So why do you need to check like the first 5 rows? Because you need to familiarize yourself with the data. For example, from this dataset, what I see and what you guys will see when you do a lot of computation is in this dataset we have a mix of categorical columns, date columns, and continuous columns. Date columns we have example. This is start dates, so don't be like confused. You can like also look at the variable definitions to understand what all these columns means. I already did that. So we have the start dates and we have the harvest dates, right? So this is the start date of when the crops was planted, and this is the harvest date of when when the crops was harvested. And then we have for the categorical columns, this is it's also a categorical column, but it's the target. So ignore these two. This is the ID, it's randomly generated. So it is not considered as a feature. It's just a unique identifier of each row. Category is the target variable. It's also not a part of the independent features. So other than these, everything else here is what we call the dependent features or the x in the y is equals to mx plus c equation, right? And the y in that equation is category in our case. So this is the dependent variable. This is the ID column. We don't care about the ID column, only a unique identifier. All these others are dependent columns. So The model needs to learn the relationship between all these columns to this to this target variable. That's basically what, not basically, I don't want to be misquoted, but in simple terms, that's what you need to do or need to train your model to do. Like from all these independent features, how do they map to the target variable? Cool. And these are the categorical columns. You can see categorical columns are like string in nature objects. These are the continuous columns. They are numerical in nature. Can see 97, 54, irrigation count. These are categorical columns and categorical columns. And now you have this special column. So remember when I told you, basically each row represents a farm. A farm is like let's say a rectangle or a polygon. Like assume a land is a polygon, and this polygon has coordinates. So for example, this will be xy, 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 and that's xy being latitude, longitude, latitude, longitude, latitude, longitude. So if you look at that column specifically, I mean geometry, if you look at the first one, you'll see it's a list of latitude, longitude pairs. Yeah, you can see it's a list. So you have latitude, longitude pair, comma separated. This is what will be used to download the images for the Sentinel too. So other than this project is very beginner friendly. So if you don't consider this geometry column, this project is very beginner friendly. But if you want to use geometry to download the images, it becomes advanced, but not that advanced because Zindi has provided you with a starter notebook. So we won't need this, so put that in mind. In our stream, we are not going to use geometry in any way. Cool. So that's basically some of the things we do when we load the data. So there's other things you need to check. So train.describe describes statistical characteristics of the attributes. So for example, of the numerical attributes. So you can see the categorical columns have been excluded because you cannot find like categorical, I mean, statistics like mean, minimum, maximum from a categorical column unless you convert them to a numerical column. So we are going to talk about that later. So you can see they're pretty standard. So for example, if you look at this pretty like from this I can see it's pretty Gaussian like. Yeah. 5, 6, 82, 120, 30, except this might be a little bit skewed. We're going to see that. So train.describe, another one is train.info. This is for inferential statistics. So this is descriptive statistics, and this is inferential statistics. What do you learn from inferential statistics? You learn about the missing values, although it's not the best way to like visualize the or see the missing values, but you can see there are no like missing values. How do you know that? Because this 8777 is repeated for every column, and if you look at the shape, it represents the train number of rows, meaning no row has a missing value. And then you can see the data type. You can see it's a combination of like object columns are the categorical columns, integer columns are the continuous columns. You need to know this because each needs to be handled differently. And we're going to talk about that. Cool. So these are the basic methods we look. So I also never talked about competition. I mean, data science, data science competition pipeline. So this is opinionated. This is mine. So the first thing you need to do is understand the problem. Understand the problem. And that is what we did on the Zindi platform. That is where we went to the info page, looked at the objective, the data, the rules, the evaluation metrics, which are pretty important. And then after you've understood the problem, download the data and then load the data. So load the data and study the data. This is what you've been doing like in the past few minutes, like data.head, data.describe, data.info. Yeah, basically. The next step is EDA. So EDA in full means exploratory data analysis. This is where you visualize the data in plots, in charts, in graphs, you name it. After EDA helps you to find insights on the data. EDA is very important. EDA is very important. So you find the insights on the data. Using the insights found from the data, you do data pre-processing plus feature engineering. This can be separated in two steps, but as I said, this is opinionated. This is how I handle it. I handle data pre-processing and feature engineering in one stage. After that, we do cross-validation. So I'll talk about what cross-validation is. After that, we do modeling. So here we do training and evaluation. After that, we do inference on the test sets. After that, we do submission. After that, lastly, upload the sub file on Zindi. That is all the steps you're going to cover today. So from here, this was stage one. Stage one. No, not stage one, stage two. Understanding the data has already been done. That is on the Zindi platform. So here is load the data and study. Then we have already done that. Now here is where EDA starts. So EDA is okay. I'm going to tell you now some tricks. You see, this stage and this stage, that is where you'll use all your brain, all your creativity. But for the EDA part, there's like you don't code a lot. Like because EDA is basically the same, not the same really, but 75% is the same across multiple competitions. So you can be clever. If you have participated in multiple competitions, you can have reusable Python code for the EDA parts. Like to create the code for the EDA, where you use your brain is understanding and deriving insights from those plots. Data processing and feature engineering, that is where you write the most code. Like that is where you write the most code, and that is where you use your brain. That is where the creativity, the main creativity of that helps you to win competitions is in these two stages. Cross validation, pretty basic across multiple competition, reusable code. Modeling, training, and evaluation, pretty basic in multiple competition, reusable code. Inference, reusable code. Submission, reusable code. Loading the data and study the data, you can create reusable code for it. So you can see like competition, but also this is this is competition dependent. For tabular data, yeah, a lot of reusable code. But for other complex deep learning tasks, there's a lot of reusable code as well. But yeah, there's a lot of reusable code. Data preprocessing and feature engineering, bro, that is where the juice is at, and you have to squeeze the lemon You have to squeeze, you have to use your brain, you have to use your creativity to the max in these two stages. For the EDA, not to write the code, but to understand the plots. And to help you with that, so I'm going to come here at my GitHub and go to my profile. And if you come to the overview, you'll see this coding with collage. All you need to do is come copy this. You don't have to do this, by the way. ChatGPT can generate the code for EDA like easily, like just prompt it. You don't have to do this. This is my own resources. So I reuse most of this EDA code. So uh so git clone. Cool. Then we need to navigate. So if you git clone, it comes to your files. You can see it's here. We need to navigate to the utils, to the utils, to the EDA. We need to access this EDA.py. What does this EDA.py contain? It contains a lot of reusable code for EDA. So you can see load datasets. We don't need this. Dataset info. We don't need this. We have already done this. But remember, we need to specify the categorical columns and numerical columns, which is easy. We need this find differential information, and you'll see why. And we need all this. Yeah, we don't need the null specific ones, but yeah, we're going to use only the ones we need. So and you can do this for your modeling. All the parts that I've said, they are reusable. You can have your own. Like if you do a lot of competitions, bro, you don't even like need to struggle with all the other stages, because the brain of machine learning solution is at the feature engineering and the data processing part. Although sometimes you have to create custom cross validation techniques, but majority. That's my own opinion. Like others may have different opinions, but yeah. So how we navigate to this? We need to like copy the path here, here, and then list here. Now, once we are here, you can say from EDA imports. You can specify the functions you want. So let's specify together. So we have said we don't we don't need dataset info. We don't need load dataset. We have already done that. So find differential info. This is important. You'll see why. So import find differential information. Then or you can use the asterisk to load everything. So you don't need to define anything. But let's go step by step, so that you know the exact functions we need. We don't need column-wise null distribution. This data has no null values, so we're going to ignore that. We need this plots numerical distribution on top of each other, and I'll tell you why. This is one of the most important one in this collection. So nice. And then we have plot categorical distribution on top of each other. We don't want the one on top of each other. We want the one side by side. Yeah, this plot categorical distribution side by side. But I remember one of these had a bug. We're gonna see. We're gonna see. If one has a bug, I'll show you another another function I'll use. So yeah, correlation heat map. Do we really need this? Okay, for the stream, for the stream. Let's do it for the stream, but yeah, we need that as well. Uh, plot relationship, plot, plot relationship is also crucial. So, but I don't think we'll do that in this stream. Maybe we'll do it. We don't know, but we'll see. We'll see. Plot target is important. Yeah, I think that's basically it. We only need those for our EDA. You actually don't need this. You can ask ChatGPT to generate for you the code. The most important thing is to understand the insights that each of these functions derive. Yeah. Or, yeah. So once we do that, now we can safely go back to our working directory, and our working directory is always content. Yeah, our working directory is always that. So if we check, yeah, so we are back to the top level. So this is the top level. You always want everything to happen here, not inside any of these. Yeah, cool. So we are cool. Now let's now start with the find differential info. I'll explain the importance of this. So find the differential info is a function that checks, for example, in the categorical columns. Mostly it's for categorical columns. So it checks if the categories provided in tests, and this is mostly location-based data, and this is location-based data, so you have to be very careful. Test might have different locations, and train might have different locations. So how do you easily know this? Because if they have different locations, it's really advisable not to train with location-based columns. Why? Because you'll be training your model to understand, for example, if you are training, if the goal was country based, for example, Kenya, Tanzania. Train has Kenyan data, test has Tanzania data, and you're training with Kenyan locations, and test doesn't have Kenyan locations. Basically, everything you've done won't generalize well in Tanzania because Tanzania doesn't have the same locations as Kenya, and you've injected the location-based data on the model already. So if you try to use Kenyan model to predict for Tanzania, it's gonna give you very bad results. So how do you check that? It's so find differential info checks if categorical values align in both train and test, which is very, very important. If categorical columns don't align, drop that column. Drop that column, don't train with it. Or use that column to find other other complex feature engineering features like location-based statistics, but later drop the location. Drop the location. Yeah. So how to call this? You find differential info. It tells you the arguments. So we have the train, we have the test, features to exclude. Yeah, features to exclude means the features you don't want to study. So you don't want to study like continuous columns. You only want to study categorical columns, and you don't want to study the target or the ID columns. So the first argument is train. We have the train, we have the tests, and the last one is feature to exclude. Feature to exclude is a list. So you provide uh, so the ID column. So we can we can have here some I mean constants. So ID column is called what's the ID column called? Form ID. Form ID. We have target column is category. Then categorical columns is equals to call for call. So list comprehension. Yeah. Numerical columns. Oh, also, before that, you need to specify the date calls. So call for call in chain dot columns if it's in call. So Pythonistas, they know list comprehension, pretty cool. Categorical column, so you need to, because date is also like categorized, like in the inferential statistics, so date is also has the type of object. So call for call in column 15 is equal to object and call not in date calls plus, because also target column, yeah, ID column, because also those are objects. Numerical columns, call for call in chain call not equals to objects. Yeah, so we can verify. So print categorical columns, print numerical columns. Cool. Oh, farm ID. Yeah, yeah, yeah. We also need to do that. Call not in ID call. Farm ID is not a numerical column, it's a randomly generated. Crop cover, tree height, irrigation count, water cover. Yeah, that's all the numerical columns. Categorical, crop, state, district, sub-district, syntax, C lost, C transp, irrigation type, irrigation source, season, geometry. We don't need geometry. We don't need geometry. So drop calls, because geometry I told you it's for the sentinel bits. We don't need that. So plus drop calls. Cool. Now we have valid categorical columns. We have valid numerical columns. So features to exclude these, everything else like date calls, plus numerical calls plus ID call and tagger call. You only need categorical columns. So actually the better argument for this function is features to include. So if you feel motivated enough, you can create an PR to fix that. So let's see. Nice. Nice. Oh, plus drop calls. I forgot geometry, man. Cool. Now we have our function. So it's pretty cool, by the way. It tells you how many unique values are in train, how many unique values in tests that are not in train, and at what percentage, right? It tells you how many unique values are in train are not in tests. How many none percentage, we don't have nuns. Percentage is the biggest categorical column. So you can see, for example, states, this already. So this is the power of EDA. Any constant, like any column you see that has only one unique value, you need to drop that column because it's not important to the machine learning algorithm. So through EDA, we have seen we need to drop states because it's only one unique value. And as we're going to see, the states, yeah, we can actually check that before we add it to the drop calls. But states dot value counts. Value counts just checks the distribution of each unique value in a categorical column. You can see it's only one state, so we actually don't need this. So we drop it. Through the EDA, we have known that. Cool. There's these other ones are valid, but the most important like attribute in this table is unique values in tests, not in train. Unique values in test, not in train. That represents the Kenya Tanzania analogy I gave you. If you train only with Kenyan locations and you're predicting for Tanzania, how do you expect the model to generalize and there was no Tanzania location based attributes, right? So you need to drop that attribute to not like uh, have good performance in the train and have worse performance on the test set. If you look at sub-districts, unique values in test, not in train, there are 35 sub-districts that are present in train, in test, and actually, if you look at how many the unique, the unique and unique sub-districts, you'll see that they are 35. So meaning all sub all sub districts all sub districts oh, all sub districts in test are not present in test. You can see like test has 35 sub districts and all of them are not present in train. So this column you should not train your model with it. So delete it. I mean add it to the drop calls. That's the power of EDA, man. That is where you use your brains. One of the places you use your brains. Okay, this is not a source of concern really, but it's only two. But these two can be make or break as well. So you need to perform experiments with districts and without to see the performance. So just don't assume. Uh, always experiment. Always experiment. But this one, this is problematic. We just need to drop it. For the others, you can see this is only one, so not a big issue. You can see all the others are clean, 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 clean. Hii nayo unique values in train are not in tests. That is not like a very big issue because if you have all the tests, all the unique values in tests are also present in train, then that is not really a problem because you already have the model will learn the all the locations are present in train, which also will be found in test. Cool. So that's why I say this function is one of the most important for me. Like I don't like all my competitions, I do this for the categorical columns. Cool. And we are done with the first one. So delete. Next, let's go to the next. Which one else do we plot numerical distribution on top of each other? So now this is the cool charts etc. So which one do we okay let's start with the continuous. Doesn't hurt. Continuous columns EDA plots numerical distribution on top of each other. If we enter, you'll see it takes in train, tests, and a list of numerical columns. So train, tests, numerical columns. Nice. So I'll tell you why this is important. We have 1, 2, 3, 4, 5. We have 5 numerical columns. The distribution in in test, because test is the most important here. We are trying to predict on unseen data. There's no place we are going to predict on train. Like you give us train and then predict on train. Nah, you predict on unseen data. The distribution in test data has to follow the same pattern as the train set. If one of the columns doesn't follow the same pattern, that means it was distributed it or sampled in a wrong way. So you should not include also that as part of your features. But this dataset is very clean. As you can see, crop covered area comes from the same distribution. Sea height, same distribution. Irrigation count, looks categorical to me because yeah, this is discrete, but comes from the same distribution. Like all of them are present in test. Water cover, same distribution. Like you can see, even this gap is obeyed in the test. So the green one is train, the red one is test data. XP, I don't know, XP yield, what, oh, expected yield, same distribution. Although this one has a, a greater tail at the end, but most part of it, same distribution. Pretty basic, and you're done. So also from this, you can check out the skewness. So cool, cool question. I mean, quick question to the chat. Chat, can you tell me what's the distribution of sea height? Sea height, what's that distribution? What's that distribution in sea height? What's that type of distribution? Tuendelee. Okay, I'll give you choices. Is it right skewed or left skewed? Right skewed, yeah, right skewed. Thanks, Mon. It's right skewed. And if data is right skewed, so we can add a note here. So insights. Uh, most, I mean, train and tests come from same distribution. Uh, C height is right skewed. Right skewed data we handle them uh, transformations to handle skewed data. We have log transforming and we have square roots square roots transforming. Don't worry if you have never done statistics, but we're going to learn. We're going to learn. So check this out. Train SNS. Did you import S? Oh yeah. It was imported in the EDA part. So was it? Did he import? How did he call it? Okay, we're going just to explicitly import it. Uh, import pandas as PD. Import Cbon. Cbon is for visualization. SSNS. So SNS dot displots displots train. Let's check the C height distribution. Nice. So this is a little bit pretty. Uh, so SNS. So let's check the effect of log transforming. Oh, I need to import like most things here. Import numpy. Numpy is used for numerical operations. Import cbon as SNS. Import matplotlib.pyplots as plt. That's for visualization. And for now, let's, because we're in the EDA part, let's stick with those. Then we later add for the modeling parts. So check this out. Cool. By log transforming, so in most cases, this is used to handle right skewness, and this is used to handle left skewness. Right skewness is data that has a long tail to the right. Left skewness is data that has a long tail to the left. What should be our interpretation and difference in distribution between train and test? A significant one. Your interpretation should be you should drop that column. You should not train your model that column because basically your model will learn how to you learn relationship and pattern in the train in that train distribution, and then when it goes to try to predict on the test sets and the distribution is different, it will struggle to predict for that distribution. So you should drop it. Yeah. Uh, it's just the same as the way categorical columns are different in train and tests. If test has categorical columns that are not present in train, you should drop that column, right? Because you don't want the model to learn relationships of that column uh, to predict on unseen like columns that are not present on the test set. So you should drop any column that has a different distribution. Yeah. Cool. So this is nearly a normal distribution because we don't have a long tail again. So log transforming, right skewness handles right skewness, square root transforming, left skewness. Cool. So that's our toolbox for you. By the way, this helps in the feature engineering process. So without EDA, you wouldn't have known this. So using your brain. But writing the code, you didn't have to use your brain. You just you needed to use your brain to interpret the plots. Cool. So I'm going to delete this, but I think you have seen. Oh, so what we have done here, we have log transformed the column. That's why it's different from this. This was the row column. So I'm going to, okay, let me just comment it. Doesn't hurt. Maybe if I share this notebook later. Nice. So numerical columns had not a lot of work to do there. So lastly, not lastly, second last, because you also need to check the target distribution as well. So, I mean, targets, not target, categorical distribution. So here we plot them side by side, and I hope this is not the one which had a bug. Anyways, let's see. So this one takes in args, a data frame, the trained data set or the single data set. So if you want to only plot for a single data set, you only provide the train and the list. So for example, I'll show you categorical call. Okay, it's good, it's good, it's good. It doesn't have a bug. So yeah, so you can see categorical columns. Telangana, we said you need to drop this. This doesn't help. Uh, you can see the crop distribution, state distribution, drop this, district distribution. Oh, so something cool. So if you want to compare train and test side by side, you just add the test to that function. And you'll see them being displayed side by side. This is for easier checking. So our main concern is the sub-district one because they had different sub-districts, right? So we need to, okay, this is a bit dirty, needs a lot of, needs some work. So, but anyway, you can see test both have single columns, so we need to drop this. Paddy, cotton, maize, chilies, Bengal, groundnut, red gram, same distribution except the Bengal gram, I guess, and groundnuts. Yeah, but Cool, beautiful plots. You can dive deeper to find more insights from this data. But one of the main insights from this, we already saw it in the find differential function, is the states. We need to deal with this, and the subdistrict, they are different. We need to drop them. Now, lastly, at the EDA stage, so that we do some other cool stuff where we train our models. So, target distribution, target distribution. So we imported plot targets, I guess. Yeah, plot targets. So here we specify the train dataset, the target column, and the objective. The objective is either classification or regression. So we have the train, target call, and objective. Objective is classification. Now we come back to why did the organizers use F1 score as the metric? This right here is the main reason. This is the main reason. This is a very highly imbalanced dataset. If we used accuracy and we predicted healthy as for all the for all the columns, man, we'll be like 99%. Okay, I wanna approximate though. We'll be almost greater than 95% accurate. But will our model be an accurate model really? If you're only predicting high accuracy on the healthy ones? The most important ones are the diseased, pest, and stressed, right? These are the most important ones. And that's why the organizers use F1 score. F1 score is used in highly imbalanced datasets. And this is a perfect example. Now, so for for experienced people, for experienced people, after seeing this, like right now, I can ultimately guess if I only submit for the test sets, if I only submit healthy as the predicted label, I would actually perform so well. Do you guys want us to try that? Do you want us to try with no ML? I promise you. Submitting just healthy will get us very high score because of the imbalance. Do you guys want us to try? Comment in the chats if you want us to try. But we'll try anyway. So, uh, we'll try anyway. So, baseline to beat. So, this will be our baseline to beat using machine learning. So, in essence, since I told you test.head is the one we need to predict, is the one we need to predict. So, what sample submission looks like, so if we read in the sample submission, uh, sample submission, path plus, yep. If we read in the sub, so what Zindi expects from us is one CSV file with the ID, this ID column in the test set, and the target variable. So our test is baseline. So let's call it baseline is equals to test select from, actually we already specified the target call, I mean the ID call. So ID call and okay, no. So let's do this. Let's actually no. Sub, we already have the sub here. So sub targets is equals to healthy. And then sub dot to is so the okay, here you're learning two lessons. Through EDA, you can see, like through EDA, you can actually see an easier way to like to the leaderboard. Without any ML, you'll submit this because of the imbalance and see which score you get. So Zindi expects you should look at the sample submission file. This is what they provide. They only lead at a CSV file with the ID column and the target column. So when you do this, when you submit, the reason why we shifted to the working directory, the top level working directory, so that this file, this baseline, when you do to CSV, it basically saves your data. So when you click the three, I don't know what they're called, you'll see the download option. Download, it will come to your to your what is it called? To your local machine. Then we need to submit. This will be our baseline to bits. So if we submit 72 and the first one had 73, bro, you can clearly see the imbalance. I see. Most people actually have that score. So you can see 72, 6140, 72, 6140, 72, 6140. So basically, most people here noticed that. Yeah, true. Also, Mon. Actually, where is Mon? Mon is number 9. At least Mon bet the baseline. But I see he also noticed that issue. So you can see when you submit these, you get 72, 61, 40, and looks like most people noticed that. And only just through EDA, now we are at position 36. Actually, there are people still, but yeah. So the goal is to reach one. Let's see if we are going to reach one tonight. One, we are coming for you. We are coming for you. Anyways, yeah. So that's the baseline to beat. So so you can write here some notes. Baseline to beat scores 0.7261 on the leaderboard. Can machine learning win? Can machine learning beat this? Can we beat this? Let's see. So, in highly imbalanced datasets, there are different ways to handle imbalance, right? And I don't know if you guys have seen the Neo ML agent that they are claiming that it's going to beat, like, it's achieving cargo level grandmaster, which is pure BS. Which is pure BS, by the way, because their evals, they're basing their evals on past competitions. Like past competitions on Kaggle have solution write-ups. The model has been trained using those solution write-ups. So they entered past competition using a model that was trained using those solution write-ups. They're claiming that their agents can now be cargo level grandmaster. Cargo level grandmaster? Are you serious? Are you serious? You know cargo level grandmasters, bro. That's crazy. If an agent ever gets to cargo level grandmasters, then we'll know our jobs are in trouble. Our jobs as machine learning engineers are in trouble. But still, I think there's a long way to go. I think there's still a long way to go. So that Neo agent, some when asked to generate, like, I don't know what it was generating, but it suggested smots. So if people have been in the data science community for a while now, smot is a technique that is used to oversample data. So in this case, What you do is you oversample this data with synthetic datasets. When you oversample this dataset with synthetic datasets, you're basically introducing noise. The best solution is actually to undersample, because while you undersample, you still retain the original datasets. You don't introduce the noise, but you reduce the imbalance. So for example, here, if we look at the value counts for healthy, it's 7,000. But disease, best stressed, they are nearly 500. So the best thing to do is to reduce these, still retain the imbalance a little bit, but in the ratio of either 1:3 or 1:2. So that's like the imbalance, because the imbalance matters, by the way, in a way. So instead of like reducing it to using 7,000, all rows 7,000, all 7,000 rows, we can reduce it to, let's say, 1,000, so that it can be 1:2. Because if you look at the row value counts, so let's see, if you look at the row value counts, uh, I mean, target call, man. Okay, come on. Yeah, if you look at the row, you can see 72, 14, and all the others are 537, 536, 488. So if you increase this to like 1:2, so what is 537 times 2? 537 times 2, 1074. We can resample these datasets to 1074. Cool. Uh, so we're going to try that. We are going to try that. Yeah, like Kaggle, Kaggle is it's a bit tricky to download the images, because you need to connect to have like credentials.json from Google Earth, while Google Colab seamlessly integrates, like the same way we are asked to allow permission for files, is the same way you'll be allowed to ask permissions for Google Earth. Yeah. So how do we resample? So we need to import something called resample from sklearn.utils import resample, and then we need to select healthy data. Healthy data is equals to trained data, healthy disease data, yeah, or other data. Disease data is not the right thing to use. Then healthy downsample is equals to, yeah, my AI is doing things for me, man. No, or even length of other data, by the way, other data, but yeah, but let's try with 1:2 first. 1074. Okay, here, 1074. So n samples, how many rows will get like eventually after undersampling. But you can also try, it's a matter of experimentation. You can also try other data later. So random states, you can use random state of your choice. Balanced data, now we can check. Great, now we have reduced it to from 7,000, over 7,000 rows, to 1,000, which is 1:2 ratio. So imbalance is a bad thing, because the model will learn high imbalance, because this is almost 1:7,000 divided by 500, like over 10x, which is very bad. So imbalance forces the model to learn only to predict healthy. But when you undersample, it makes it a bit generalizable, a bit. That's up for experiments. So let's see, man. Let's see. So we have a baseline to beat. Next stage is feature engineering. Feature engineering, and we are going to use the undersample data. Feature engineering and data processing. Cool. So how I like to do this is defining one function, feature engineering, and then it takes in the two datasets, and then eventually it returns the two datasets processed already and selected columns for machine learning for ML model. So what happens here is data is equals to, you concatenate the two so that you can process them only once instead of doing processing twice. But this is only advisable for competitions. In a production setting, like real world case, you need to process them individually. So, I mean, data is equals to, you concat them. Once you concat them, remember we have date features. So define get date features, takes in the whole data, and also this, it returns the whole data, but with the new features. So for call in date calls here, because they are objects, you need to convert them to date and columns so that you can do some cool things. For example, if you want to get the year, all you need to do is data.call.dt. This is only possible because of this to date time. So you can get the year, you can get the month, you can get the date, and you're concatenating with the original columns because there are two date columns. So we loop through the two and calculate date features for each. Then we need the year, we need the month, but you don't need the date. Remember, this is harvest data. Do you think the day will affect harvest anything? I think the year and the month are very important. We don't need dates. We don't need day. We need day. We don't need day of week, but we need day of year. Yeah. We need week of year as well. Plus, yep, not day of week, week of year. And we don't need this. We need dot is calendar. ISO calendar here. We don't need all these. We only need those. Oh, quota as well. We don't need that. Quota. Quota. And also, we need data duration because we also need to see how the whole planting to harvesting cycle took. So it's a data start end date, harvest date, I mean, minus S dates. Actually, we can do this in one liner. We don't need many lines for this. So you do that dot dt dot days, how many days, dot as type int, and you have all your date features. That is part of your feature engineering. So this is where you use your brain. Through the dates, I saw the dates. I saw we can calculate date features. So data is equals to get date features, and you have your get and you have your date features. Also, when I looked at CNext, I mean CNext means crop next, and C last means crop last. So which crop was planted last, and which plant was planted, and which plant was planted last. So we have C next, crop to be planted next, C last, crop to be planted the last, previously, I mean. That's what I guess, yeah? So we can create a new feature that represents this pattern. So this feature will be called data. You can call it anything, but last to next. Uh, Actually, do we have a feature that tells us which crop has been planted right now? We do, and it is crop. So we can map that pattern by the way. So it's last last because last was the previous, then current, then next. We can go crop last current next. And how we do this is we concord last c last dot as okay, yeah, it's, it's cool to do that. So we don't have c current, AI stripping, crop. Is it crop type? Yeah, crop. We have crop, and now we have a cool feature. This is a cool feature, and we'll see if it's actually cool. But but in AI, machine learning algorithms only understand numbers. But remember, we have categorical columns, including these we have created right now, which are in string format. We cannot feed them directly like this. We need to convert them into numbers, number form, numerical form. So how do we do that? So sklearn. So now we are going to import feature engineering imports and cross-validation imports and modeling imports. I'll explain each. Feature engineering or preprocessing. So from we have scikit-learn, which is so cool. We have preprocessing, has preprocessing, and we have cool methods like label encoder. Label encoder converts categorical columns to now numerical form. We have also another one called pd.dummies. pd.dummies does something called one-hot encoding. One-hot encoding is given male or female as gender types, it will create two. So gender, you have one column gender, right? It will create two columns called gender male, gender female, each with 0101 with binary values. But label encoder will retain the same column gender, but change male to 0, female to 1, and it will retain that one column. But one-hot encoding, it will create a column for each category. So it will create, if you have 10 categories, it will create columns for 10 categories, each with 0, 1 binary values. But label encoder will retain the original column and change the 10 categories to numerical format in the form of 0 to 9 because there are 10 categories. I need to finish this because I'm feeling my voice is kind of going, man. But yeah, but we have to learn. We have to learn, man. So yeah. Oh, we have not finished. We have not finished importing. So standard scalar, we want to use standard scalar. Standard scalar is used to make all numerical columns conform to uh, the as a given distribution. Yeah, we have min max scalar 0 to 1. Standard scalar. No. Standard scalar is the one from 0 to 1. Ensures all numerical columns conform to 0 to 1 distribution. And min max uses min max to create the standard distribution. We are not going to use that, although. So we have also metrics. The metrics we're going to use. Metrics imports. We are going to use F1 score. Then cross validation. So we have sklearn or metrics imports train test splits. I don't think I'm going to, although I don't think I'm going to use train test split, but we have a robust one called stratified k-fold. Oh, by the way, stratified k-fold can handle the imbalance issue. but not that 10x imbalance issue. The one we have created right now still has an imbalance of 1 is to 2, and that can be handled by stratified cable by making sure the distribution in each fold. Okay, maybe I'm using fold and people don't know what folds are. We're going to talk about that. What am I missing? Oh, so we need to initialize the label encoder. We need to initialize the label encoder. Yep, I think we are done. Oh, yeah, no. We need to import my favorite machine learning model. But anyway, we're going to use a simple today. It's called sklearn.ensemble. Imports. So in machine learning models, we have linear models, we have gradient boosting decision trees models, we have neural network models, we are like MLPs, we have KNN, unsupervised machine learning models, we have support vector machines, we have a lot. You need, if you can look at them later. Classifier. We are going to use a simple random forest classifier today. If we want to use a robust one, we are going to install one my favorite machine learning model. Pip install CatBoost Quiet. CatBoost is my favorite machine learning models. With CatBoost, you don't need to worry about hyperparameter tuning. Instant, powerful, but takes a lot of time. Takes a lot of time to train compared to others. But instant, no, it gives you accurate results even without hyperparameter tuning. But all these others like XGBoost, like GBM, you need to tune them. Random forest classifier, I think not really, but let's see. I've not used random forest classifier in a while, but I think for this tutorial we can use it. Ah, so let's import cat boosts just in case. Just in case, import cat. You can import it any way you want, but this is my way. Cannot import. Ah, I see. Train test. Okay, we're not going to use this anyway. We're going to use a robust because of the imbalance. Stratified k-fold. Bro, are you kidding me? Model selection, not metrics. I think that's why. Yeah, we're cool now. I was worried. Yeah, we're cool now. Now the fun part is starting to take shape. Training machine learning models. This is what people love. But before that, for call in categorical columns, plus our newly created column. No, use label encoder. Label encode everything. We're not going to use PD dot get dummies because as I explained, things can get pretty columns can get pretty they can get a lot. That's the correct terminology to use because each category has its own column. So yeah. We're going to start with label encoder for the time being. For the for our illustration. I think that's it. Oh, we can also because we saw uh, C next was a bit red skewed. We can factor that in. So we had C next here is equals to np.log1p np.log1p. Don't worry. These are you learn these things as you go on. They're not complex to be honest. Plus, if you have done computer science or any mathematic related units, you've probably learned about statistics. Um, yeah, and we are done. all you need to do is selected columns here. So selected columns is everything in data.columns. If call not in, if call not in what? If call not in drop calls, you don't need any of the drop calls. If call not in ID call, target call, we don't need the original date columns because we have already created date features. And what else? What else we don't want? I think that's it. And then, oh, we need to return the train and the test. So data, data, ID call, dot is in train, ID call, dot unique. In short, we are trying to separate the train and test from the original concatenated data, and we're using the ID column. So anything that was present in the IDs of the train, we reassign them to train, test, we reassign them to test. And we are cool, our function works now. Our function is complete. So imagine in your machine learning competition journey, this is the most important, this is the most important function you'll ever write. This, that, this is the brain of your machine learning projects. This is what wins you competitions. It might look so simple, but let's see in my recent open source solutions. By the way, I open source all my solutions, by the way. You will see the same pattern. The same pattern I've used here is the same pattern. So let's start with the plastic cover one. I have not like this is still private, but I'll release it. Modeling. Let's see the same pattern is the same pattern in all tabular competitions. Okay, based on myself. So you have EDA here, lots of EDA. Now, I told you it can get pretty messy, pretty messy. Can you guys see? Nice. Now look, this is the brain. You can see. By the way, even in this, we'll have to calculate all these vegetation indices using the polygon we dropped. Remember, but we are keeping everything very simple, very simple. But this function is the brain that wins you competitions. I'm telling you for sure. This is the brain that wins you competition. This whole fish engineering block, modeling, this you can like this is very usable code, but this varies competition by competition. So that's one. Let me show you another one. You'll see the same pattern, the same pattern. Except for the okay, these are the planning one. Vegetation mapping, human settlements. Yeah, this was a bit not tabular in a way, but this I ranked second, so it was showing, but you can see the same. Although here this was a little different because we were loading H5 data, but you will see the brain of the competition, like the brain that won me the competition. Okay, made me second. It's the same things you saw in there. Like, bro. Anyways, time. Let's get back. You have seen. So this is where you win, and hopefully we'll win as well using this. Anyways, so how to call this function? We do train that test df is equals to uh, which engineering. I hope it works. Train df dot shape train dot shape just to confirm everything is in order. Train is the original one, and test is the ISO, bro. is okaledo. Inaitagwa aje? Is okay. Is okaledo. Kuna vene. dt.isocalendar. Yeah, isocalendar. Ah, wait. I had that too. No? Yeah. Wacha tuone. Series object has no attribute isocalendar. Am I doing this wrong? Okay, try cloud. Let's ask cloud to the rescue. Because I remember I used this recently and it's ISO calendar. I mean, I don't know why it's. Hmm, are you kidding me? DT maze, DT ju. Series object is not callable. Like, are you kidding me? What? Yeah, sorry. Too many values to unpack. Obviously, cool. They match. So it's 75, it's 75, that is 16, that's 16. You have not messed anything up. And you also need to confirm the selected columns, not so that you don't leak any values. Crop states. I thought we added state to the drop calls, no? We don't need states. I mean, yeah, we added it. So why? We added it. So yeah, looks better now. So we have crop, district, sub-district, C height, C next, C last, citrus, season. Yeah, season. Yeah, looks cool to me. Also, let's confirm that the object columns have been handled gracefully. Selected columns. Head. Nice. We don't have any, so everything has been converted to numbers. So the machine learning model won't complain. So, to the fun part. Oh, not yet. Why are we rushing? Cross validation. Now we are going to go with a complex cross validation technique, but to explain it haraka haraka, not haraka haraka, so that you understand. Certified K fold images. So I'll explain using images. Yeah, this explains it visually. Cool. So in certified K fold, so let's start with the basic. Train test splits. What happens in train test split? In train test split, you want to simulate the train test relationship that has been provided by the competition. How do you do this so that you evaluate locally? Si lazima, si kila time you train on your local machine on the whole data, then you go submit to Zindi to check the leaderboard score. You'll overfit to the leaderboard. You'll overfit to the leaderboard score. But, but, if you want to compare your scores locally, so that, you know, you have to like have a certainty of how if you are improving your models. And how will you check that? Through local validation. So what certified K-fold does, it creates, so this, assume this is one train test split. So you have 80% training, which is the blue one, and 20% the red one. You leave it aside for validation. But in train test split, you only do that once. And this, with the imbalance in our data sets, you might randomly sample the data in a biased way. So there's bias in your trend test splits. But to minimize this bias and to ensure generalizability, you have to validate on all the data that you've been given in a clever way. And also you have to train with all the data in a clever way. So how will you do this? So you divide your whole data into folds. Folds ni kama day 1 to day 3 is equals to fold 1. Day 3 to day 5 is equals to fold 2. Day 5 to day 7 is equals to fold 3. Day 7 to day 10 is equals to fold 4. In that case, you have 4 folds. So you train kwanza na all the data from day 3, which is fold 2, to day 10, which is fold 4. So fold 2 to fold 4, and you leave fold 1 for validation. In the next iteration, you use fold 2 for validation, but train on the fold 1 you had held out in the previous iteration. So you're training with a validation that you had held out before, meaning you're training with the whole data. So if you go through the whole iterations, utakuwa you'll have trained with the whole data and validated the whole data, and then you have 5 scores. So if you have 5 folds, you will have 5 scores based on that splits, based on those splits. For example, here you'll have score 1, assuming that is trend test split 1. You will have score 2, assume that is trend test split 2. For score 3, score 4. And then eventually you find the mean or the average of that score, of those scores, of those 4 scores. And that will be your score that will be aiming to improve. So that's K-fold for you. So here it's called K-fold, but this is the parent. Stratified K-fold. K-fold is for regression. Stratified K-fold is for classification, for stratifying with a target column. Yes, don't msichoke. Don't get tired, don't get tired. You're nearly there. You're nearly there. We are nearly there. Karibu tunamaliza. Ah, so how is this cross validation done? It's actually okay. This is reusable code as well, but I'll code it for you. First, you have to define the cross validation. So SKF. Remember we imported stratified K-fold Ukonju. So K-fold. Here you define those splits. So in our case, we are going to use for time we are going to use 5 splits, and then then we are going to do some shuffling. And then because you're doing shuffling, you have to specify the states. The seed. So 42 is, and then since we are not like doing cross validation while training, we want to calculate the folds before. So that's like ensembling, all those stuff can be seamless. But you're not going over ensembling right now. So so we are going and I forgot. Here we are not supposed to use the original train. Remember, we have the balanced data, balanced, what is it called? The one we undersampled, because we don't want to train, balanced data. We don't want to train with this imbalanced data. We want to use the undersampled data that we used. Yep. So time data does not match formats at position 1. You might want to try. Okay, okay. Uh, let's start session. Why is it saying this though? For call in date columns, chain test, get test feature. Okay, let's retry this again. While it's running, let's write our cross-validation technique. So we have trained the F. We are going to create fields for only the train data. So train the F fold, initialize it to -1 for fold comma underscore validation idx. Okay, this is a bit technical, but don't worry, it's reusable code. You can copy paste in multiple projects. Fold dot value counts. That will create for us our folds. So time data. So this is coming from balanced data. So let's see. Balanced data dot head. Ah, I see. PD dot to datetime. So this is 11/12/2023. This is it month? Hey Jamini. Dates dot value count. I mean unique. S dates. Okay. Day, month, year. Day, month, year. Cool. Cool. Format dates. Wait a minute. I hope, I hope both. I hope both are in these. I hope both. Let's check, man. I hope. Yeah. We are cool. Format is equals to day, month, year. So we can delete this now. You can delete this, yeah. So here we need to compare with the balanced data. Nice. But still, yeah. But anyway, we now have a reduced. Okay, we can check. Next, we are going to try with the language other data, but we can check the target call if it's still 1074 dots value counts. Oh, and also remember we have not converted this target column to categorical. Okay, we are still good. That's all. Now you'll see the folds in action. You'll see the folds in action. Shuffle is equals to true. Shuffle. Bro, we don't have shuffle. Are you serious? We do have shuffle. Oh. Yeah, obviously. Here we need to reset index so that our index are correct or are following each other. And we don't have missing indexes because that causes issues with stratified careful. Nice. So each fold, so we have 5 folds. So in essence, what this means, we'll use fold 2 for validation and use all these others for training. And then in the next iteration, so it's a for loop. We are going to use this for validation, the fold 1 for validation, and then 2, 4, 3, 0 for training. Fold 4 for validation, 2, 1, 3, 0 for training. Fold 3 for validation, 2, 1, 4, 0 for training. Fold 0 for validation, 2, 1, 4, 3 for training. That's stratified k-fold or k-fold, whatever you want to call it. But stratified for classification, k-fold for regression. Yep, and we are now ready for the fun parts. Now we train our model. So the code here, uh, kid notes, bro, you'll reach this level one day, one day. Just keep on pushing. Don't give up, man. Don't give up, my bro. Don't give up. Don't give up, my bro. So modeling is a bit technical, and that's I was saying we reuse code because you write the code once and then you reuse across multiple classification. You use across multiple classification, but I'm going to write it from scratch. Am I going to? Yeah. So we're going to define our model. We're going to start with random forest here for a, a quick one. N estimators. N estimators will be not 1,000, maybe 100 for the time, and then 4. Okay, why is it doing this? I don't know why it's doing this, so let me refresh. Kidogo. I hope it will fix it. Yeah, iko sawa sasa. So remember the fold we created, so we are going to do for fold. Oh, specify n splits. N splits is equals to train df. We already know the n splits, but to be sure, and unique just counts how many unique folds there are there. For fold in range, oh cool, call my AI. Training training is equals to train df, train df. Now see what I explained. See what I explained. We are going to use the fold since we are iterating over the number of folds. We are going to use everything other than that fold we are in for training. And then validation, the same thing I explained. It uses the exact fold we are at. So kama tuko fold 0, it will use fold 0 for validation and all the other folds. This means all the other folds for training. That's the beauty of cross validation. Now we'll have 5 different models trained and 5 different model predictions. Cool. So we are going to have OOF predictions. These are overall predictions of the train based on the based on the, what is it called? Based on the out of folds models, like the models we are training during the folds. Cool. My AI knows training. So independent features, all the independent features are called selected columns. The dependent features target columns. So we're creating X train, Y train, Y X val, Y val. This will be familiar to guys coming from train test splits. In train test split, we do the same. X train, X val, X val, uh, Y train, Y val is equals to train test splits. Then you do the same thing. But now here we are not doing only a single train test split. We are doing it inside folds. So we're going to model fit chain. Then let's see if my AI knows. Okay, yeah, it does. So we are going to save the OF predictions. We are going to save the test predictions, but also we are going to, yeah, it knows. Not macro, but weighted because it's multi-class. Print fold one F1 score. Is it correct? Is it correct? Then yeah, we are good to go. We are good to go. Will it train? Let's see if it will train, my guys. Uh, I don't know if random forest has verbose. I really am not sure. Does it have verbose? Really? No, it doesn't. So let's see if it will train. Ah, so to see which fold is being trained, actually, this should not be training fold, but validating on fold to know which fold. Yeah. Yeah. We are good to go. Are you guys excited for the next? What is coming next? Yeah. Aye. Here for the test, for the test, we're going to do model dot predict probabilities. Axis is equals to 0. Yeah. Let's see if so that we can do the mean. If we do the model dot predict, if we do the model dot predict, if we do the model dot predict, we will have to calculate the mod of the five folds. So why is it failing? Could not convert. I see. We have not converted our target variable to numeric. Is equals to the fit transform chain target call. Man, this shit excites me. Like, I love writing code for machine learning competitions. They're so cool. Also, we need to save the mappings. Yes, sir. Let's do that. Cool. And we have our mapping. So desist is mapped to 0, healthy 1, best 2, stress 3. We're going to use this later. Could not convert. Bro, chain the F because we are at chain the F, man. Yeah. Are you kidding me? Okay, random forests. Random forests doesn't have axis. Uh, Overall F1 score 0.29. Hey, this F1 scores looks so bad. 0.29. Are you kidding me? Well, let us submit to Jue if we are on the right progress or not. Let us submit. But okay, I'm going to, yeah, I'm going to reuse a certain code ya kuangalia on how to check feature importance. I'm going to reuse one of my codes here. Yeah. I don't. The writing that code is a bit long, but it's reusable code anyways. I hope random forest has feature importance, just like my favorite cat boost model. By all GPT models do have that. So instead of x dot columns, just selected columns. Not LHBM. Random forest. Okay, random forest has. So we are cool. Nice. So duration is the most important feature in random forests. H date, subdistrict, cool. Some cool stuff. Yeah. Okay. Now the next. We have already performed inference, by the way. So the last step is submission. So I'm going to go back to the code. Up to here, from here to here, we are doing what is called training plus evaluation. Here we have not touched the test set at all. But here it's where the stage called inference. Now we are predicting on the unseen test data. So that's why you're using test predictions. But our F predictions for the false prediction. So submission, we need to, since we stored the test predictions in a list, so if we check test predictions, you'll see it's an array of 1, 2, 3, 4, 5 of the 5 models we used. In each fold, we trained a model, evaluated it, then performed inference. So at the end, we had 5 models performing inference. Now, to find uh, a flattened lists of predictions, we have to find the mean. Predictions. Cool. And we have our array. So length. Uh-huh. Uh-huh. 4. Nah. We don't need. No. This. Oh yeah. 4 classes. And we need to find the np.argmax. Uh, okay, chat. Don't worry. We are nearly there. We are nearly there. Hit notes. We are nearly there. We are nearly there. We are nearly there. Okay, predicted class. This okay. This is not okay. Yeah. If you have not used NumPy before, it's going to be a bit technical. So let's see. Predict the inverse transform is performed by the label encoder we transformed. The axis 1 is out of bounds for array of dimensions 1. Okay. Ah, test predictions. Yeah, why am I reusing? Ah, come on. I have to repeat, but it won't take long. No. This looks 10,000. Kidding me? Ah, yeah, that looks more like kids. This should give me the same as test.shape 0. Let's go, let's go, let's go, let's go, man, let's go. But we're not there yet because predicted classes is a list of integers. Yeah, and remember we need to return this in. We need to return this list of integers to their original classes. So we need to form a class mapping. A class map like we need to use our mapping. We can use label encoder.feature inverse, or we can use these. Let's see if my AI will help me here. Okay. Predicted classes. I don't want to repeat. Original predicted classes. Original. Nice. Now we have the original. We have the original classes. After what is remaining is assigning this to our. Okay. Let me comment this out. So we can now assign our predicted classes orig, and now we can check id call targets dot head. Looks good to me. Test targets dot value counts. Bets if this will beat our baseline. I'm skeptical though. Baseline. Okay. Before we do that, dot rename columns is equals to farm ID to ID. It's how do they want it? ID target. Okay. ID target. Yeah. Okay. So let's name this random forest. Yeah. That looks better. Now after you download it, you come here, you submit. Hopefully, uh, let's see if it will beat our baseline. Oops, oops. It doesn't beat our baseline. It doesn't beat our baseline. It doesn't beat our baseline. So this baseline is very hard to beat. This baseline is very hard to beat. Let's try cut boost. So we're going to comment this out. Model is equals to cut boost. cat boost classifier, man. Uh, Random states is equals to 42. So we have model. Now cat boost now has verbose. So verbose is equals to 50. Random state, I mean iterations is equals to 100. Cool notes. Ah, I see, I see. So the reason why it's doing this is because this needs to be flattened. Bad CV though than random forest, but for this crop covered area is the most significant. Predicted classes, class mapping. Uh-huh. So random forests, notice the distribution. Cat boost. Okay, okay. Also, this it's going to be like I think it's going to be like random forest as well. So submission cuts, even worse, even worse. So let's we have to beat Mon. We have to we have to beat Mon. We have to beat Mon. We have to beat Mon. Okay, I'll be back. Okay, okay, okay. Let's get back to it. Overall F1 score 2706. Mm-hmm. This is going to be worse because they have the same distribution until you get a different distribution here, then we'll submit again. And also let's change the verbose here to like 200 because this is too verbose. And here let's now change, let's see the effect of changing the folds, if it will have an impact. Um, and let's return here. Let's return our random forest because this is the model that performed good for us. I think, if it's random forest again, we have to change this because our random forest doesn't have a boss. Uh, increase the iterators. Let's see, and then a submission random forests two 500. Yeah, 500 representing the number of iterators. Mon, your score is too hard to beat. Will we beat your score? Will we beat your score tonight? Damn. No, we have to. We have to beat the score tonight. Tonight. We have to. Mon, Mon, what are you saying? The feature engineering is not fun. We are not beating your score. Like, bro, come on. Come on, bro. How are we not beating your score and you're telling us, oh, bro, is this okay? Until we beat Moan's score, bro. Let's see. I don't have high hopes in this one as well. The distribution is the same. Yeah, yeah. Something we have to do something differently to beat Moan. We have to do something differently. Let's see. Uh, another thing we can do instead of this, we can play with the sampling. So instead of let's and change the random states to yeah, yeah. Okay, verbose. We are changing iteration. Verbose is equals to 200. Let's see if we are good. If you don't beat money, this, I mean, I'm going to sleep, man. I'm going to sleep. If you don't, come on, bro. I already did that, no? Cannot convert healthy to floats. Are you kidding me? Where is selected columns? Targets. Yeah, I see, I see. The public LB isn't very reflective the entire time. True, 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 true. With this imbalance, first of all, I'm expecting a huge shakeup at the end. Um, hopefully, if the distribution is the same, if the distribution is the same like in both train and tests, but I doubt it. I doubt it. I think the test is a bit better. I think the best. There's no way they can put like such a distribution in the test sets. because the most important categories for me, to me, my own opinion, are the ones which are the diseased, stress, and stressed. Because healthy, it's easy to detect healthy, but healthy, does it help in your business case? It's important to detect the diseased ones. Okay, I really I don't even know what I'm saying, but I don't think the distribution is the same like the train. The train is highly 10x 10x and more imbalanced. So there will be a huge shakeup. My bets, my bets, my bets. But let's see. If I don't beat you after this, man, I'm going to sleep. I'm going to sleep. Then we can try to beat you in the next one. But the baseline is so hard to beat. Yeah. As we have seen, the baseline is hard. It's hard to beat the baseline. It's hard to beat the baseline. But don't worry, we'll get there. We'll get there. We'll get there. 19, that's in. Okay, this will be worse. This will be worse. This will be worse. This will be worse. I'm pretty sure. Yeah. 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 Okay. One last one, then I go to sleep. One last one, then I go to sleep. Yeah. Let's go back to our random forest. At least this is giving us some hopes. But one last one, then I go to sleep. We try again another day. Uh, what I'm going to do is increase this to 2000. Yeah, increase that to 2000. Then submission RF 500 2000. I think. Uh, okay. Don't tell me I have to download the images to beat the top guys. I cannot beat the top guys with this simple model. I have to download the satellite images to beat the top guys. It's not a hard thing to do, honestly. Yeah. I just never wanted to show you in this stream because it's going to be like very technical for beginners. But in the next stream we have to. In the next stream we have to. Yeah. In the next stream we have to. The distribution of target also counts to some extent. Yeah, yeah, yeah. It does. It does. If I over now I have oversampled the data. Not oversampled. Like I had reduced it to like 1,000 twice, 1:2. Now I've made it 1:to nearly 4, but 3.75 there. If this improves the model, then I'll just keep on improving the sample until, but this is bad because now we are optimizing our score for the public leaderboard. What happens in the private score? This is going to be tough. This one is going to be tough. That's why the money, that's why the money, that's why the money, that's why the money is there. Like this one is going to be tough, and there's going to be a lot of shake up. A lot. Yeah, 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 yeah. I just improved the like I just improved the distribution, and now we are at 72. So I'm pretty sure if I continue doing this, let me now make it 3,000. But bro, I can't even trust this. You mean no, 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 no. But anyways, we are going to see. We are going to see. Now let if this now gets me more than the baseline, I'll just keep on improving this end samples to but I mean the last one, try without resampling. If it doesn't measure on one class, then these are good results. Okay, okay. Let me do it 3,000, then I will do that. I'll do that. Actually, I think it's me and you now on the stream at the moment. So, but I think I'll upload the recording tomorrow. I think, yeah. Let's see, let's see. Now we are at 3,000. Let's see if it's good. If it's good, because even, but nah, you know, this fold F1 score is like biased to the imbalance because now it's detecting a lot of a lot of healthies, and now not not a lot of the other classes. But this is tricky. This is tricky. This is one of those tricky. I remember. You remember the other one, which there was a huge shakeup. What was it called? It was the same like this. It was called what? Digital green. Digital green. Yeah, this one, man. Bro, I was really shaking out. I was really, look, I was really shaking out. Some people like really climbed the leaderboard. For example, 429, 102. So this is going to be one of those, my bets. But maybe it's going to be a close one than we think. I can I even trust this distribution, man? For my sample submission, like only 10? Bro, nah. Even if it scores highly on the leaderboard, I'll be a bit skeptical. A bit, no, I'll be very skeptical. Uh, okay, we do this, then we do one without sampling. Okay, 7253. We are improving, but still, we haven't bet the baseline yet. So 70. Honestly, I don't trust this. I don't at all. Okay, last one. Last one. We end the stream. 7,000. Let's see, let's see, let's see. The last one that we end the stream. But I thank you everyone who has joined the stream tonight. You've really made my night, honestly. First stream. Feedback will be appreciated. Mon. How was the stream? How can I make it better next time? Uh, yeah, feedback is appreciated. Anyone who is listening at the moment, feedback will be appreciated. Yeah, honestly, the F1 score is biased to to the imbalance. But let's see how it will perform. Pretty sure it will predict all the healthies, just like the baseline. Baseline is so tough to crack, but if the first person has 73, yeah, this is good. This is good, but not like so much. 72, 61, 73, or 5. Yeah, this is good. This is good. Bro. Yeah, this no, this is just the same as the baseline. Okay, I'm done. I'm done for the stream tonight. Goal is to beat the baseline before the next stream, then come show you what I did. But thank you so much. Thank you, man, Mon. Thank you so much. This was so dope. I've learned a lot. See in one more dimension right now. Thank you, man. All of you guys who have joined the stream, you have made my day. Oh, my night. And I hope to see more guys on the next stream. So, thank you. Bye. Have an amazing night.